Hello everyone, welcome to Pre-Algebra Module 3. In this module we're going to talk about decimals. In particular, this section, I'm just going to remind you of what decimals are. So this is just going to be an introduction to decimals. We will also do some conversions, right, between decimals and fractional form, and then compare decimals a little bit. And then in later sections, we will add and subtract, multiply and divide decimal numbers. Okay, so let me start by just writing down a particular number. Let's say 35.71. Okay, so the 35 is really the whole number part. So I'll say this is the whole number part. Then of course we have the decimal point. And then to the right of the decimal is going to be the fractional part. So the 71 here is a fractional part. All right, so just like we did with whole numbers, I want to start by looking at a place value chart. Okay, so let's see what each place, each of those digits represents. So let me write out a place value chart. So place value chart. Okay, so I'll write down some number. Let's say 752.1478. That'll be good. Okay, so to the left of the decimal, that's exactly what we had before, right? Because you can think of it as a whole number, right? It's the whole number part. So this is really the ones position, right, where the 2 is. This is the ones. Then to the left of that is the tens, and then the hundreds, and so on. So that's the same as before. Okay. In fact, if you want to write it in terms of powers, remember this, the ones position is 10 to the 0 power, right? Because that's equal to 1 by definition, anything to the 0 power. Then I have 10 to the 1 power. Then this would be 10 squared. So I just increment the exponent by 1 each time. Okay, so this is really ones, this is tens, this is the hundreds, and so on. To the to the right of the decimal now, I look at the fractional part, and the position that the 1 is in is the tenths with a th. So tenths, and then hundredths, again with a th, then thousandths, with a th, then 10,000ths, and so on. In terms of powers, you can think of the exponent as being decremented by 1. So if I go 1 down from 0, this will be 10 to the minus 1. And we'll talk more about exponents at one point, but really you can think of this as this really means 1 over 10, right? 1/10. Then the hundredths place is 10 to the minus 2, which is 1 over 100, right? So it's hundredths. Then 10 to the minus 3, 10 to the minus 4. So 10 to the minus 3 would be 1 over 1,000, right? So that's why it's in the thousandths place. And then 10 to the minus 4 is 1 over 10,000. And it keeps going, right? If I go further to the left, I add to the exponent. If I keep going further to the right, I'm going to subtract from the exponent. Okay, so again, it's powers of 10, right? Each position is a power of 10. Okay, just like we did with the whole numbers, let's talk a little bit about word names. Let's say Let's say I want to write this decimal value in words. I'll use 0.72. Okay, so since the 72 is to the right of the decimal point, the way I write this is I write down that entire number, so this will be 72, and then I give the place of where the rightmost digit is. So I need the place where the 2 is, and we know in this case it's in the hundredths place, right? So this would be 72 hundredths. So I write down the entire number, and then I give the place of the last digit, right? The rightmost digit. Let's do another one. Let's say I have 3.89, right? And I want to write that in words. So now, how do I handle the left side, to the left of the decimal point, the whole number part? Well, I just write it like I normally would, right? So this would be 3. The decimal point, this is where you use and. So it would be 3 and, that comes from the decimal point, the and here. And then I would write 89 and I have to give the place of the last digit, which is the 9, and that's the hundredths again, right? So this is hundredths. Okay, here's another example. Let's say I have 370.081. Okay, so the whole number part I can write as 370, right? Just like we normally would. And then if I read the number to the right of the decimal point just as a whole number, it's going to be 81. And then I have to give the place of the rightmost digit, which is the last digit, which is the 1, right? So it's going to be it's in the thousands place. So this will be thousands. Again with a TH. Okay, so really that's all there is to writing word names for numbers. Right? The left side, which to the left of the decimal point, the whole number part is just like before. Then you write and to represent the decimal point, and then to the right of the decimal point, you write the name of the entire number there, and then you give the place of the last digit, right, of the rightmost digit. Okay, often we may need to convert a decimal value, right, so in decimal notation, to a fraction, right, in fractional notation. So let me show you how you would do that. Let's say you want to convert I'll just say decimals to fractions. Okay, so for example, let's say I'm given a number and it's in decimal notation. And I want to convert it to a fraction. So there's several ways you could do this, right? You could say, well, if I look at each digit, right, in that decimal value, the 7, that is in the tenths place, right? So really this is equivalent to 7 times 1/10. Plus the 2 is in the hundredths place. So that's equivalent to 2 times 1/100. So I could write this, right? So this is 0.72. I could write this as 7 tenths, right? If I multiply that out, plus 2 hundredths. That's really what it means. And then we know how to add fractions together, right? I need the lowest common denominator, which is 100. So I could rewrite 7/10. I could multiply by 10 over 10. The other one's okay. So this is the same as 70 hundredths plus 2 hundredths, which is 72 hundredths. And then, of course, you could even simplify this, right? It looks like 4 goes into both of them, so you could simplify this if you wanted to. You can think of 72 as, let's see, how many times does 4 go in? It looks like 18, right? So it'd be 18 over 25. And that would be the answer. What's a quicker way of doing this? So this works, but let me show you a quicker way. So if I start again with 0.72, if I want to convert this to a fraction, then remember, fraction is always going to be a whole number over a whole number. So in order to make this a whole number, I need to move the decimal point 2 places to the right, right? I need to move this 2 places to the right, and then it becomes a whole number. It becomes 72. Well, what can I multiply to move it 2 places to the right? I can multiply by 100, right? If you multiply by 10, it moves 1 place to the right. 100 is 2 places to the right, and so on. But I don't want to change this value. I just want to rewrite it so it's a fraction. So I can't just multiply the numerator by 100. I also have to multiply the denominator by 100, right? This has to be a factor of 1 here, because I don't want to change this value. I just want to rewrite it in a different form. So if we do that now, so I have 0.72 times 100 is going to be 72 over 1 times 100, which is 100. And again, we simplified that to 18/25. Okay, so here's another example. Let's say I want to convert 9.8 to a fraction. Well, I can think, if I want to make this a whole number, I need to move the decimal 1 place to the right. So I need to multiply by 10, but I also need a 10 in the denominator, right? Again, because this has to be a factor of 1. I don't want to change this. I just want to rewrite it. And now if we multiply this out, 9.8 times 10 is 98, and then 1 times 10 is 10. So it's 98 over 10. And then we could simplify this, right? It looks like, let's say 2 goes into both of them. So I could, 98 divided by 2 is 49, divided by, and then 10 divided by 2 is 5. Right? I took out a factor of 2 over 2, so I just simplified it. Or even if you want to write it in, since it's an improper fraction, you could also write it as a mixed number. So if I divide this, right, 49 divided by 5, this goes in 9 times with a remainder of 4, right? So I could also write this as 9 4/5. So there's many ways of writing the answer. But the goal here was to convert the original decimal value into a fraction. What if I had this value? Convert that into a fraction. Okay, so I need to multiply, right, by 1,000 to move that decimal 3 places to the right to make it a whole number. So I need to multiply by 1,000, but I can't just put 1,000 in the numerator. I also have to have it in the denominator, right? Because again, I'm not changing this number. I'm just rewriting it. So this will be 318 over 1,000. And of course, that could be simplified. What if you have a whole number piece as well? Okay, so let's say we have something like this. Let's say we have 5.012. I'm going to write that as, let's say I want to write that as a mixed number. Well, this means, right, this means 5 plus 0.012. So I really just need to convert that second piece into a fraction, right, the decimal piece. And I can do that by, again, multiplying by 1,000 over 1,000. So this will be 12 over 1,000. And it looks like 4, right, goes into both the numerator and denominator. So 4 goes into 12 3 times. 4 goes into 1,000 250 times. So now this is the same as 5 plus 3 over 250. But remember, as a mixed number, this means 5 and 3 over 250s, right? That's another way of writing 5 plus 3 over 250. So that would be the answer. Okay, so sometimes we have to convert from decimal notation to fraction notation. Okay, next thing I want to do is review how to compare decimals. Like, how do we determine which one's larger, which one's smaller? Okay, so comparing decimal values. So, for example, how do I figure out which is larger? Let's say I have 0.731 or 0.74. By the way, you can always write a 0 in front, right? So if I just want to write 0.731, it's just cleaner to write 0.731. It means exactly the same thing. Okay, so the way that you do this is you line up all the place values. So I'll write down both numbers here. And if you're missing something, you can put a 0 in, right, for that position. So 0.74 is the same as 0.740. And then all we do is we compare the numerals, the numbers at each place value, right? So 7 equals 7, right? 7 equals 7, but 3 is less than 4. So that means that 0.731 must be less than 0.740. Right? If they're equal, you go to the next place, right? The next digit, you compare them, and then you can determine which one's greater by looking at each particular place value. So here's another example. Let's say we want to compare (0.235) to 0.2355. Okay, so I have 0.235 and then 0.2355. Because I have 4 digits, right, in the second decimal value, I went all the way to the 10,000th place. In the first number, I'm just going to put a 0 there, right, so they match. So notice here that if we compare the 10th place, the 2's are equal, right? So that's fine. So we have to move over to the 100th place. Oh, the 3's are equal. Move to the 1,000th place. The 5's are equal. Move to the 10,000th place. And then we can see that the 5 is greater than the 0, right? So that means that this number is greater than this number. Right, 0.2355 is greater than 0.235 because it's really the same as 0.2350. I suppose in the previous example, right, it really did ask which one's larger. So we would say, we could write it this way, or we could say that the 0.740 is greater than 0.731. So really this one is the larger one of the two. Okay, so that's all you have to do to compare them. Write them next to one another, like line up the place values, and then compare the digit in each place value. So related, let's say we want to rank numbers, right? So let's say I want to rank these decimal values from smallest to largest. So 0.002, 0.2, 0.02. So if I line these up, right, I have 0.002, 0.2, so I need to put 2 zeros there so it matches, and then 0.020, put a 0 there so they all match. So definitely the largest one right? Right away, we can tell that the largest one must be 0.2, right? Because the 2 is greater than the 0 and greater than this 0 in the tens place. So that's going to be the largest. We want to write from smallest to largest, so I'll write the largest over here. Then I move to the hundredths place. And it looks like this 2, right, is greater than 0, 0 here. So like this one is the second largest one. So I'll write that here, 0.020. And of course the smallest has got to be the remaining one, which is this one, right? This will be the smallest one. The other way to think about it, right? This means the one I circled in green is 2 thousandths, right? It's in the thousandths place, 2 thousandths. That's less than this one. So this is 2 thousandths. The red one is 2 hundredths. And then the blue one, largest one, is 2 tenths, right? So 2 thousandths is less than 2 hundredths, which is less than 2 tenths. Actually, let me do it in the same color. So the green was 2 thousandths. That's less than the red, which was 2 hundredths, which is less than the blue, which is 2 tenths. That's the other way of thinking about it, right? You could think about it in terms of fractions as well. But it's easier just to compare the digits at their place, right? Compare to place values. Okay, and then the next thing, actually the last thing I want to talk about in this section is rounding, how to round decimals. So rounding decimal values. So I'm just going to say the rules are similar to those for rounding whole numbers. So we already learned the rules for whole numbers, right? So I'll just write the rules are similar to those for rounding whole numbers. Okay, so actually let's review that, right? Remember, if we want to round a whole number, let's say we want to round, I don't know, 5374 to the nearest 100. Okay, so remember I underlined the hundredths place, which is the 3 here. I look to the right, the tens place. If the number is 5 or greater, then I have to round up, so I have to add 1 to the 3. If it's less than 5, then it stays a 3, and then everything else becomes zeros, right? Once I change the number I'm rounding to, the underlined number, then everything else becomes zeros. So in this case, since I have a 7 there, this has to go up to, the 3 must go up to a 4, and then everything else becomes zeros. Okay, so it's very similar to decimal values, except if you're rounding something to the nearest like 10th, 100th to the right of the decimal point, then instead of making everything else zeros, you just drop everything else, right, after you've rounded. So let's talk a little bit about that. So for example, let's say I want to round 3.5902 to the nearest thousandth. Okay, so I go to the thousandths place, right, which is the 0 here. I look to the right, 2. It's less than 5. So the 0 stays a 0, right? And now the rule is everything to the right of that just drops off. So this would be 3.590, and that would be the answer. That would be the result here. Okay, let's say another way you could ask this, let's say I want to round some number, let's say 8.009 to 2 decimal places. Well, what does that mean? It means I want to round to the nearest hundredth, right? If I want 2 decimal places. So I find the digit that's in the hundredths place, which is the 0 here. I look to the right, it's 5 or greater. 9 is greater than 5. So that 0 has to increment by 1, go up by 1. So that becomes a 1. And then everything else drops off. So this would be 8.01. That would be the number to round it to 2 decimal places. Okay, now this next example, let's look at a decimal value, and we'll just round it to different particular places. So let's say I want to round 0.978 to the nearest, let's say, hundredth. To the nearest tenth, and let's say to the nearest 1, right? So let's do nearest hundredth first. So I have 0.978. So what digit is in the hundredths place? Well, that's the 7. I look to the right, since it's 5 or greater, that 7 has to go up to an 8. So this is going to be, I'll write approximately, because it's rounded now, to 0.98. Right, so that 7 goes up to 8, everything else drops off. If I want to round it to the nearest tenth, okay, so let me write my number down again, 0.978. So the tenths place is this 9 digit, right? It's in the tenths place. I look to the right, a 7, which is 5 or greater, right? It's greater than or equal to 5. So that 9 has to go up to a 10, but I can't put a 10 there, right? I can put the 0 there, and then the 1 has to go carry to the ones place. So this is really going to be equal to 1.0. And it's important that you write the 1.0 because we want this to the nearest tenth. So I have to see the tenths place. And then if I wanted to round it to the nearest 1 place, then the ones place is where the 0 is right now, right? So I look to the right, it's a 9, it's 5 or greater, so that 0 has to go up to a 1, and then everything else drops off. So this would just be 1, and there would be no decimal point or anything like that. It's just 1, right? So that would be to the nearest ones position. By the way, if you wanted to round it to the nearest 10, let's say you have, so now we can think of it like this, right? 00978. Here, so this 0 is a tens place. I look to the right, it's 0, so this is just going to be 0, right? This whole thing is going to be 0 if I run around to the nearest 10. Okay, and then let's finish up the section by looking at a couple of problems from your MyOpenMath homework. So question 4 here says, write 1 in 19 10,000ths as a decimal. Okay, so we know that, right, first of all, we have the whole number part is the 1, right? Then the decimal point. And then we want 19 10,000ths. So the 10,000ths place is got to be where the 9 is, right? So remember, this is going to be the tenths, hundredths, thousands, 10,000. So I guess this is going to be 1.0019, right? And then that would be correct, right? So this would be 1 and then 19, and then remember we give this place, which is 10,000. So 19 10,000ths is 0.0019. Okay, question 5 is similar. Write that number, that fraction as a decimal. So 7 over, this is what, 100,000? So the 7 is in the 100,000s place, so this is the tenths, right? Hundreds, thousands, 10,000s, 100,000s. So it'll be 0.00007. The other way you could do this is you could simply divide it out, but we haven't really talked about division yet. So when we talk about multiplying and dividing numbers to get decimal values, then that's another way you could actually solve this problem. For now, we could just think about it. We know it's 7 over 100,000, so the 7 here must be in the 100,000s position, right? So 0.00007. Okay, in this question, question 11, it says select the correct inequality to make a true statement, and your options are going to be less than or greater than, okay? So we want to compare basically those two decimal values, right? So let me write them on top of one another. So I have 0.1209. I'll line up the other one, 0.129, and then to match them, so they both have 4 decimal places, I'll put a 0 there. So notice here that in the tens place, the 1s match. In the hundreds place, the 2s match. But in the thousands place, the 9 is greater than the 0. So this number is larger, right? So the second number is larger. So how does this compare to this? Well, it must be less than, right? If 0.129 is larger, then that means 0.1209 is less than 0.129. Okay, and then this problem was just a rounding problem, right? Let's say, round the following to the nearest hundredth, okay? So in this first case, right, the hundredths place is going to be the 5. I look to the right, since it's 0 is less than 5, that 5 stays a 5, and everything else drops off, right? So this is going to be equal to 0.05. In the second number here, I have 0.006, right, 6 thousandths. So again, the hundredths place is the 0, so I'll underline it. I look to the right, a 6, which is 5 or greater, so that 0 has to go up to 1, right? I have to add 1 to it, and then everything else drops off. So this would be 0.01. And then the next one, I have 0.096. Okay, so I want to round to the nearest hundredth. So that's the 9. I look to the right. Well, 6 is greater than or equal to 5, right? So the 9 has to go up to a 10, but I can't put a 10 there, so I can put the 0 there, and then the 1 has to carry over to the tenths place, right? So this is going to be equal to 0.10. And notice that when I write the answers, right, they all have 2 decimal places, right? So they're all rounded to the nearest hundredth, and that's what we wanted. Okay, great. So that's it for the section, just an introduction to decimals. Next, we will talk about adding and subtracting decimals. Thanks.